we first need to, step 1 and 2, we first need to come up with our population set of quantitative data. Okay, I picked just exponential. I wanted something that was very much not normal. Okay, so you pretty much just need to follow the instructions. Go into the simulate function, create a column of 4,000 random variables that follow an exponential distribution model with mean of 10. Okay, so that's under StatCrunch. It'll be under data, simulate. Okay, I said an exponential model. That's one of the models there. And then you'll notice they said mean of 10. Exponential, it only has one parameter, the mean. So just 10 goes there. I wanted 4,000 in a column, so that means 4,000 rows, one column. And then usually I stack it with an ID. Okay, we're not doing math on this one yet, so we're not doing any computation. We're just generating 4,000 exponential. Okay, so you hit compute. So I want you to look at that generated histogram. Make sure you trust that it looks like an exponential model. So do a histogram on that exponential. You don't really need to set anything else. Does everybody agree that looks like kind of a decaying exponential? That's what it's expected. But very much not normal. Very highly skewed. That's what I was going after here. Okay. Okay, so that's part 1 and 2. Part 3, now we're gonna sample this. So now we're taking our population distribution, the exponential, we're gonna sample from it 100 at a time. Okay, and we're gonna create hopefully something that looks like a normal model, because that's the central limit theorem. Okay, so we're gonna use the sample function in StatCrunch. We're generating samples of size 100, but we're gonna do it 500 times. Okay, so that is, if under data, under sample, we're sampling from that exponential that we created. Sample size was 100. I was going to do it 500 times. You need to replace the data because we only generated 4,000. And then here we do need to do a computation. The idea is, what do I do with all 100 samples? All we want to keep is the mean value of that 100 sample. So I'm going to go in here under compute statistic. We're going to find our mean function, add that, and then what are we taking the mean of? The sample of our exponential. And that's it. Say OK. It just populates the script here. And then say compute. That's all you got to do. So we have 500 values here. Think of this as 500 different samples that you've done or experiments. We're going to histogram that just because we want the shape. So if you go under graph and look at histogram, but of the mean this time, it looks pretty normal. Okay, like a normal model. So the idea here is from an exponential, something that clearly isn't normal, when you're doing samples of it, they suddenly nicely start looking like a normal model. So here's the theoretical, I'm sorry, these two guys. Here's the theoretical values. This is what we expect our sample model, the mean to be, and the standard deviation. One thing, I mentioned it last time, the exponential has a mean of 10, sigma is also 10. Okay, so in here we're gonna do 10 over radical 100, that's 10 over 10, that's 1. So we expect a mean of 10, a standard deviation of 1 in our sampling model. Let's test it. Let's take the summary statistics of this sample, the sample means. And you got a mean of 10, a standard deviation close to 1. That's all we're looking for. Just that to show that, hey, yeah, we're getting numbers close to what the central limit theorem is saying. Okay. So I want you to compare these two with theoretical. That's it.
But if you're comparing the theoretical, you just have to do the actual work.
Yes. Yeah. And just remember, for an exponential, the mean is equal to the standard deviation. So they're both 10.
They're both 10.
Yeah, that's only true for an exponential model. Okay.
Thank you.
You bet. Thank you. See you later.